Okay, hopefully you see my screen. Welcome everyone. People would continue to trickle, and I'll keep an eye on the. So from time to time, I'm going to kind of stop briefly just to see if anyone is having a question or anything like that in the chat. So yeah, if you want to use the chat, you please do. So this is our 14 meetup. It's the second virtual one. And again, I'm gonna kind of repeat myself. I didn't realize that it's gonna be that long when in March, when I decided not to have the meetup. I thought it's a kind of a one-time thing, and we're gonna be back to business in April, but it didn't happen. So last month was the first one, the first virtual one, and this is the second one. And let's continue. And the meetup fees are really paid by Qualcomm wireless R&D solvers in San Diego. So this is my regular slide. I don't know if there's any new people joining here. If you are new, raise your virtual hand. I'm not. There's a few people that I can recognize. I recognize Tom, of course Marshall, but I don't recognize the other one, so I'm not sure. But it's basically kind of a call for talks, and again, it can or maybe should be a short 20-30 minutes fun talk about anything that you can think of. There's a lot of topics in C++, especially these days with the standard C++20 that is already done, and we can there's a lot of things that we can extract from the new standard in order to be familiar with the new things. And but also the 11 to 17, there's a lot of things that we can learn and extract. And if feel free to approach me and ask for guidelines, and I'll be happy to give you topics. I have gazillions of them. So for this meetup, for today, the agenda would be the following. There's all kinds of the regular stuff. So we'll take a look at the GitHub repo of the month, which would be the named type repo, and we'll show some examples. We'll show a lightning talk from Cohen-Arazi, which I mentioned his name a few times throughout the past few months. So this is from CPPCon 2019. And this is actually one of the lightning talks that I actually missed. I think it was kind of overlapping with another session that I attended. Then we'll take one lead code from one of his talks, one of Connor's talk, just one of them, and take a look at examples of how to solve that with using stud algorithms. Just a single C++ Stack Overflow question, but something very basic. It's actually not really a C++. It's more C-ish, and it's really basic. And again, I'm trying to kind of balance the content with all kinds of variety of from beginners to experts, which experts is really something that is really light. We want people to feel comfortable in not getting lost. We'll have maybe one or two C++ quiz, book recommendation, and this meetup we'll have two. We have a talk from Marshall Glow, about 20 to 30 minutes, and the title is Customizing the Associative Containers and Sorting Algorithms. And thank you, Marshall, for volunteering for that. And I have about 20-30 minutes on stud variant, and this is basically something new that I'm gonna try. This is gonna be a interactive session, and if you are part of Qualcomm's Teams channel of C++. So in Qualcomm, we have a C++ team channel that I'm the organizer. And every Wednesday, so I have two things there. One is the daily C++ tip, which is maybe a short snippet of code and things like that that people can learn. And every Wednesday, and this week it's going to be Friday because I have a conflict. Every Wednesday, I have an interactive session, about 20 minutes, about just a topic that I pick, and it's about 15 to 20 minutes. And it seems like people really like the interactive part of that. So I'm going to give it a try here as well. It's similar to what I had last week with some additional content that I didn't have time because it was about 20 minutes and I'm going to have another 5-10 minutes here. So, and Marshall, you can start and I can do the other one like after you. So that's up to us. Okay, just to let you know, we have the Dropbox link. I copying the content every month to this link, so you can have actually the recording. I'm not sure I'm copying because I have limited storage there, and I need to think what to do with that. So the recording, I started recording last month. This is actually our second recording, so I'll see what what can I do with the storage. So we don't have the recording yet uploaded. Okay. Any questions, by the way, before I start with the content? Yeah. Okay. This is very interactive, so please stop me if you have any question. Okay. So the GitHub repo of the month is name type, which is under Jonathan Bursera. I don't know if I pronounce his last name correct. He's the owner of Fluent C++ blog, which we actually looked at in one of the previous meetup. And his repo name type, it's actually a very nice idea. Let me just browse to this repo just really quick so you can take a look at. So this is the repo. And the idea is really to take primitives like double, float, integral types, and make them strongly typed types instead of like loosely typed. And I'll show an example and actually using this idea to show an example. So so I have a link here to Godbolt. Okay, and let's take a look at what this library can bring it in terms of capabilities and how, in my opinion, it can make your code safe. So first of all, this is Compiler Explorer, which I using throughout the meetup a lot. It's actually something that I'm using a lot in my day-to-day job. If I want to try something small, at least once a day using it. And one of the I started using it a few years ago when it was all this feature was very limited in terms of features, but now it's like it's very rich. It's pretty fun to use it. One of the things that you can see here is that you can actually add all kinds of libraries. There's like a huge variety of libraries, and you can see this name type. Hopefully you can see my pointer here. Just say yes or no. Yes, no?
Yes.
Yes, okay, thank you.
Yeah,
so
sorry.
Yeah, no worries. So just make sure that I'm when I'm pointing something, you actually see. So you can actually choose whatever you want in a specific library, which is pretty fun. And this name type, I actually added this maybe a couple months ago, and because I wanted to showcase this library and all, and I thought this is a very useful library to look as an example to write a better, more type-safe code. So I added this. I created a merge pull request, and it's being accepted. And I think was like 2-3 weeks ago. And it's pretty straightforward to edit. It's not like rocket science or anything like this. So so I'm glad that we have it, so I can actually show you how it actually works. So you can include, once you pick the library, you can include name type HPP, and it's under the Fluent namespace, and Fluent because Jonathan's blog is Fluent C++. So let's take a look. This is main. Let's take a look at a very simple example. So let's say you have a width and a height, okay? And some semantics, it doesn't make sense to kind of do any arithmetic on. For example, it doesn't make sense to take width and height and to plus it. Just like it doesn't make sense to take a kilometer and meter and add them. Like if you have a 2 kilometers and 1 meter, if you do plus, it's going to be 3, but it doesn't really what you want because the units are different, and there's like countless examples of this kind of mixing units doesn't make sense. And there's also a very famous stories about spaceships that got broken because this mixture of units was done accidentally. So there's a lot of libraries out there that gives you units, and this is something similar to what they bring with some additional features. So this, of course, does not make sense, right? So let's start to see what Fluent library provides us in order to get it more type safe. So you let's say we want to have double as our type, and we encapsulate that into this. So there is a template type that, and we're using here a type def. And the interesting part is that we're using like template tagging. So if you go and take a look at the library, which is pretty straightforward, the idea is really great. And then the library is pretty straightforward to understand. This struct with tag is actually doesn't exist. Like there is, if you look at this code, there is no definition of this struct. It's pretty much just tagging of the template. And if you're using templates, you probably heard the name tagging maybe in some literature that you were reading. So I'm just making up a name, and by making up a name, I'm creating here an instance. Sorry, this is a type. I'm creating a type that is, and I'm creating a type that this type is really different from the other type because I'm using a different tagging here. So width tag and height tag, and I could come up with any name that I want to. There are two different types, and I'm going to create an instance of this type here. So I have a width and I have a height. So that's good. So first of all, I cannot do this anymore. I cannot take width and I cannot do plus. So that doesn't work because I cannot mix these types anymore. So this is going to be a compile error. This is already a benefit. But on the other hand, we don't have things like I cannot do plus plus to a width. If I want to do, let's say, width plus plus, I can't have it. So what the library provides us is a set of capabilities that we can add to the type, basically to the template. So I named that type improved width. So it's a type def of all of that. So it's basically the same tag, but I'm adding more capabilities. And if you go back to the GitHub repo and you take a look at the documentation and the headers, there's multiple capabilities that you can add to your type. So I decided that this type is addable and subtractable. And I can also make it printable, and I have an example in the next few lines. So I have an improved width instance with 5, and now I can actually, since it's edible, I can take this improved width and I can do plus improved width. So that would give me the sum of the width. And I cannot print it. Yes, I need printable. So let's take a look at other examples. Basically, you probably understand the basic idea. It's pretty much self-explanatory at this point.
Hey, Kobi, I
Yes.
have a quick question.
Yeah.
When you mentioned the width tag and the height tag, can you just like what are they like? I know that the type of their argument is like double, but what does the width tag and height tag does to?
Okay. So net type have these two headers. So the implementation would have let me see here. So the T would be the actual type, would be the double null, and this parameter is what I mentioned as the tag. And the idea is, and Marshall, if you have a better way to explain that, please chime in. The idea is that when I put here a specific and I tell the compiler, look, this is a struct. The compiler would take it as is. It's a valid syntax. I can't explain more than that. So once I provide a specific struct foo, it becomes part of the type. So if I put a different struct name, it's a whole different type. Like this.
Yeah, it's basically it's a disambiguator. It's a way of distinguish between width and height. You have width tag and height tag, which are so now width and height are different types, and they're no, even though they're specializations of Fluent's name tag, there's nothing to do with each other. So you can't assign one to each other. You can't you can't convert or any of those things. Without those tags there, they'd just be a struct wrapping a double, and they'd be compatible.
Yes, right, exactly. This is basically just a trick to really to distinguish between the types. And if you look closely, this parameter is not being really used at all. Again, just to create this distinguished type. It doesn't use it anywhere. Like this is just a type def. You see what I'm saying? And we're gonna have like because I had a request coming, a session, maybe few short sessions of templates, and this would be one of the things that we can cover. And for now, just accept the syntax that we can. This name type has accepting a type and some parameter that would help us to distinguish between these two. In this case, it's type def, but between these two full types.
Got it. Thanks, Kobi.
You're welcome. So, okay, so one of the things that you can, okay, so this is basically improved height that I created here, and I created a incrementable, and now I can do plus plus. So basically, this is another, they call it skills. It's another skill. Now, a bonus thing that nothing to do with this library, but just something that I wanted to show is that you can always attach, when you deal with units, just like Chrono has the Chrono literals, and we have all kinds of other literals, for example, string view and string and other literals. You can have your own literals. And this is just a kind of a syntactic sugar to when dealing with units. So the syntax for that would be you have some return value, and the return value type is this type. Just created just a type that in this case is also printable. And so this is like, it looks very funky syntax, but you just need to accept that this is the syntax. So there is this operator, and then since it's a user-defined literal, the standard asked us to start with an underscore, and then I can put here everything, and I just super height sh, and then a long double v, and I'm creating an instance of this super height. And basically, when I create this 17.0 underscore sh, I'm creating a super height, and I actually can print it. And you can see here that it's printing 17. And this, again, I like when I deal with units and I need to have this kind of syntax, whether it's in the production code or maybe in tests. I really like to have this additional syntactic sugar, and then I can do auto, something like a number, and then underscore the string literal, and now sh would hold the type that's being returned from this function. So this is something that is really nice to have if you're dealing with units. And that's it for the name types. Any question on this one? Okay, perfect. Let's continue. Okay, let's do, this is about 5-6 minutes of CPPCon 2019 lightning talk from Connor. And hopefully you can hear it. And this was the end. So of course we need to start from the beginning.
How's everyone enjoying CPPCon? All right, my name is Connor Hoekstra, and welcome to my CPPCon 2019 lightning talk entitled C++ 23 ranges, slide and stride. So we are going to start by looking at 3 algorithms that are going to be coming in the C++ 23, hopefully, ranges library. Those are sliding, chunk, and stride. So the function declaration of each of these looks very similar. They take 2 parameters, an integer k and a range. So sliding might look like this, chunk might look like this, and stride might look like this. If you are a functional programming enthusiast like myself and you love Haskell, the type signature of the equivalent function in Haskell would be the following. So an integer, a list of A is a generic type, and then returning a list of A's. So for our C++ functions, those are going to be returning a range of ranges. If we take a look at what these algorithms do, sliding with k equal to 4 and our list of integers 0 to 9, it starts by looking at the first 4 integers and then takes a step, looks at the next 4, takes another step, and it continues to do this until we end up with our final range of ranges that's going to look like this. The different ranges are separated by colors. Chunk with k equal to 4 is a very similar algorithm, but instead of stepping by 1, it steps by the size of the chunk. So we look at 0 to 3, then 4 to 7, and then we have a partial chunk at the end, 8 and 9. So this is going to give us the following range of ranges. Finally, stride with k equal to 4 looks at 1 element at a time, and it strides by 4. So we first look at 0, then we skip to 4, then we skip to 8. This is going to give us a range of ranges 0, 4, and 8. Note that we might just want this to be a single range, so we could use a Haskell concat or a Pythonic join or a range v3 join. So Kotlin, a little shout out to Phil and JetBrains here, has an algorithm called windowed. The function declaration of windowed is as follows. We can ignore the third parameter, but most importantly, we have 2 integers, size and step, where step is defaulted to 1. This is what it might look like in C++, 2 integers, nk and a range. And once again in Haskell, we just have an extra int in our type signature. So why is this important? Each of the 3 algorithms we just looked at can be implemented in terms of the Kotlin windowed. When step is equal to size, we get chunk. When step is equal to 1, we get sliding. And when size is equal to 1, we get stride. In Scala, this is called sliding. Note that the default here is not equal to 1. We have an overloaded version of sliding where it just takes a single integer and the step is hard-coded to 1. In dlang, or D, this algorithm is called slide. Note that the parameters here are called window size and step size. So Kotlin calls this windowed, Scala calls this sliding, D calls this slide, Haskell calls this divvy, I don't know why, and very unfortunately, Clojure calls this partition. So if we take a look at 5 more languages, and we look at each of these 4 algorithms, the Kotlin windowed and the chunk sliding and stride from the range v3 library, we end up with the following diagram. So first we're going to look at the most consistently named algorithm, that's chunk. So that's where the step is equal to size. So you can see here a number of the different languages call this something slightly different. Haskell is chunks of, Elixir is chunk every, D and Rust are chunks, F# is chunk by size, and Kotlin is chunked, but I like the algorithm name chunk here. I might prefer an S at the end to be consistent with D and Rust, seeing as those are our sibling languages, but chunk it is. The next most consistently named algorithm is stride. That's where size is equal to 1. You can see here we're being consistent with D. 2 other names for this algorithm are take nth from Clojure and take every from Elixir. But for the next 2, we have some ambiguity. For when step is equal to 1 and we just are stepping by 1, or when we have a specification of step and size, we have 2 choices, either sliding or windows. So if we're consistent with Scala and D and range v3, we get sliding or slide. But if we're going to be consistent with Kotlin or F# or Rust, we're going to call it window or windows. Note here that Rust and F# don't have the 2 integer parameter version. They just have the sliding where a hard-coded step is equal to 1. So the question is, should we be consistent with D or should we be consistent with Kotlin? I'm not sure if Andre is here. I invited him. I vote for D. You can see how happy Andre is because of this. There's a number of motivations for this, though. One, I think the semantic meaning of slide is closer to what this algorithm is doing. We were sliding across the screen. The second reason is that it has the same tense as stride. I think it's a bit weird when windowed is in past tense and stride isn't, so slide and stride is a little bit more consistent. And so I prefer the slide over sliding. Also, Windows is an operating system, and that makes it a little bit hard to search for if you're on Google. But most importantly, whether we call this slide or windowed, what I want is a version of this algorithm so that we can implement chunks and the hard-coded where the step is equal to 1 and stride in terms of this algorithm. So that gives us the following. And if you like this kind of stuff, hit me up on Twitter. Thank you.
Yeah, I definitely recommend following him and looking at his talks. There's a lot of good things, and we're actually going to jump into one of his talks where I kind of cherry pick some of the algorithms that actually he's showing lead codes and things like that, and how to implement it using C++. And sometimes he adds all kinds of other languages like Haskell and things like that. Okay. So this is from Better Algorithm Intuition from Meeting C++ 2019, and I think in CPPCon he had two sessions on this specific domain. Again, I recommend to watch that. It gives you a lot of good perspective of what's out there in the standard library in terms of algorithm. There's a lot of things there that we can use and we should use. And it helped me a lot, by the way. Okay, so a question, k-closed points to origin. We have a list of points and find the k-closest point to the origin 0, 0. And this is the Euclidean distance. You may return the answer in any order, except it's guaranteed to be unique. Just the order doesn't matter. And this is a big hint, by the way, the order doesn't matter. Okay. So what we could do is basic. So this is k-closed. We get a vector of these vectors and k. And we need to, so there's let's say 10 points, and we need the 5 closest. Okay, so what this solution is doing, it's okay. I'm going to sort this whole thing, so it's taking square root of a times a and a0 times a0 and 1 times 1 and so on and so forth. That's easy. And then it just returns a vector of from begin to all the way to K. So that's fine, that works. We'll see that it's might doing more work than we need. And here, by the way, there is this thrust library, which is similar. So it's like the CUDA standard library, I would say, something like that. Okay, so obviously we can definitely remove this square root because we don't really need the square root here, right? So it's the same. This is the same thing, but no square root. So that's save some CPU cycles. Okay, so what can be done better? So in the standard library, there's a lot of there are a few algorithms that are kind of in the domain of sorting, and partial sort is one of them. So there is this full sort that we just mentioned. This is partial sort, and this means that, look, I have this begin and end. So so there are three iterators here. So the begin and end, and I want to sort this range begin and end as it, just to give me the case sorted, the first case sorted one. So this is the syntax. So the begin and end will be the first and the third argument to this algorithm. And then we need to provide an iterator to the point where we want it's going to be sorted from begin to this point, which is the plus k. Again, we have this lambda, this is simple, and then we basically just return this vector from begin to k. This is already better because we're not going to sort the full array, and this is good because no one asked us to sort the whole array, just they asked us to get the k closest one. And the best approach here, which is the most efficient out of these three options, which we saw partial sort, would be the nth element. I don't know how many people know about the nth element, but I wasn't really aware of it until like a few months ago when I started digging into this standard library and watching Connor's talks. And I realized that this actually can help with some use cases where I don't really need to sort the whole thing. And the nth element just give you, so when you say I have a beginning and I have a range, and I just give me the top k elements, then not necessarily need to be sorted, but I know that less than this position are smaller or equal to this specific value, and everything beyond this value, like indices wise, is bigger than this value. If you think about Q-sort and things like that, basically it's like you pick a pivot and then you put it in the right location where everything before is smaller or equal and everything after is bigger. So this is basically kind of the building blocks of quicksort. And again, we return the vector from begin and to begin plus k. They are not sorted, but they are the closest k. And this is the best probably approach in terms of efficiency. Any question before I go to the next 3-4 slides related to this? Any questions related to this? Okay.
Not a question, just a comment that there are probably 7 sorting algorithms in standard library.
Okay.
They all do slightly different things, and some of them are much more expensive than others. Like stable sort is the most expensive of all of them. And whenever you sort stuff, you should in fact think about what you need. Right? There's partial sort and stable sort and nth element and so on and so forth, and stable partial sort and so on.
So thank you. This is really this is a great addition. Just like Marshall mentioned, there's a lot of them out there, and obviously stable sort is even the sound stable sort sounds very heavy. Obviously, it needs to keep the relative order. Let me see. Okay, here, sorting. So there is sorted, checks whether the range is sorted until. So is it sorted to a specific point? Probably there is an, yeah, there is a basically a iterators that it's being used. And there's just ignore the overloaded with the execution policy. Of course, there's comparison. One of the things that I realized a few months ago is that I need to really look carefully on all the overloads, because the overloads might have, especially if, let's say, if you look at stud transform, it's not a sorting thing, but there's lots of overloads. Some of them take 3 iterators, some of them take 4. So carefully take a look at that. Sort, partial sort, copy, stable, and nth element. So yeah, be familiar with this, because it's really good thing to understand and get a really good handle on. Okay, so this is basically from the heaviest in this specific talk, right? Obviously, stable sort is heavier, partial sort and nth element, and he mentioned that one of the talks from Kate Garroy, naming is hard, let's do it better, when she mentioned about naming, and this is what he actually tries to say here. And there's a sort, partial sort, and partial sort copy. And he said, basically, it's not the best name. If you think about nth element, it's basically the top n. Would be probably a better name. That's what he's saying. So he's saying here with set and under the set, we actually got, at least this is his opinion, we got the naming correct. The nth element copy, and it's basically like a top n, and partial sort copy would be the top n, but they are sorted. So basically is just suggesting a better naming to these algorithms. And partial sort copy, let me take a look. This one, I haven't shown that, but it's basically the nth element, but they're actually this nth element actually now sorted. That's it for.
No.
They're not sorted?
Partial sort copy does not change the
No, the copied one is sorted. Yes. Yeah, this is why the copy. Yeah, this is why the copy. Yeah. Sorry. Thanks for the refinement. I'm talking about the copy one. Okay. Stack Overflow of the month. This is really, really, really basic, but I actually saw a couple of these in the past week. Simple question. Why does const car pointer no need to address to point to? Like, you point to something which is not an address. Why? Like, why you don't have to do this? And basically, the simple answer, and I have like kind of more elaboration on that in my slides. This specific declaration is as if you had this specific declaration, and then A points to this to the address of where Anthony string is, like resides. And you see this little book of pointers, and this is actually a very small book. It's like, I don't know, I have it. It's like, I don't know, 60 or 70 pages, maybe 60, but it's really fun. It's really everything you need to know about pointers inside out. Like if you are confused, and this is really like if you are kind of coming from a different language which doesn't have pointers, and although in C++ we have a lot of, in modern C++ we have a lot of ways to describe syntax or content without actually need to deal with raw pointers, it's always a good idea to understand what's happening behind, like under the hood. And so you need to excuse me, I kind of took a few pictures from this book. And this actually comes from C, and just kind of a fun basic facts. So C doesn't have a dedicated string type, right? It's basically a bunch of array of characters, and it treats the null character, like 0, as string terminator. So when you declare a string like this, C automatically adds character to the end, right? So this, if you do size of, it would be the number of characters here, and that's it. But there is the amount of space that it's actually the whole thing takes is another. There's another character, but size of would give you just the size of without the null character. This is straightforward. Okay. So is an array a pointer? So what this specific paragraph says that if you have string as an array and you have pointer string, both of them are actually addresses, right? But is str1 and str2 both pointers? They are not really pointers. And many programming books and tutorials, they say that array identifiers are pointer variable. This is incorrect. It is essential feature of a variable that it can be, the value can be actually changed. So str2, you can take str2 and assign it something else. But str1, you cannot go and assign something else to str1. If you try, you will see that it's not going to work for you. So the value of this array identifier cannot be changed. Okay, a pointer variable occupies one address. Its value can be set to point to a different address. That makes sense, right? It's a variable. Array identifier and its address are one and the same thing. So what does it mean? So when I have str1 equal hello, basically the address of str1 is the address of the first character, whatever the address of the first character is. So in this case, it's 73396. So if I have str, so this one, you see on the bottom, str1 hello. So basically, let's say that the address is starting from 733. When you have str2 goodbye, basically you have str2 as a variable on the stack, and then the data points to some value that, like, this goodbye resides in some place. And so if you look at the addresses, this 137 is some address remote from the 733, right? The 733 of str1 is very close to the 733 of str2. Both of them are kind of allocated on the stack. So if you do the math, it's like this. If you look at what happened on the stack, so str1 would, so there is an array of characters, and they start with 7339688, and as you know, the str2 would be in the lower address value in the stack. So if you do the math and with alignment of pointers and all, you'll see that 676 match this address. So the address on the stack would be this one. So you cannot take str1 and assign it. It's not a variable that you can assign to something. It's not a pointer like str2. Hopefully this image makes sense to you, and this is really, I know it's basic C and all, but it's always fun to take a look at this stuff. Okay, C++ quiz. Any question, by the way, before we take a look at C++ quiz?
Hey, Kobi, can you like by the end of the session, like will the slides be shared just
Yes.
for
Yes, the slides are going to be uploaded on the Dropbox. The only thing that I mentioned is that I don't upload yet the recording, but I'll find a way. Worst case, I'm gonna upgrade my Dropbox or something like that. So yeah, but the slides are all the slides from the first meetup, and the content and everything else is in the Dropbox.
Thank you.
Okay, so let's have one or two C++ quiz. Okay, so according to C++ 17, we have this. I don't know if we already done that, but this is completely random. So okay, so first of all, before I forget, let me just copy that here. And so what do we have here? We have a struct A. It has a constructor that prints A. It has a copy constructor that prints B. And it has a virtual function that prints C. Nothing fancy about the virtual function. There is no inheritance and all. The only thing that I can think of when I see virtual function without a destructor that is also virtual, it's a kind of if you run client ID, I bet this client ID would say something here. Okay, so we create two instances of A, right? Everyone agree here? Okay, so at least we have two constructors. I don't know if I hear people. Let me see. There's people that actually writing stuff. Oh, someone says something about. I'm sorry, Jack. I missed your. Please, I don't always look at the at the uh, at the chat, so feel free to talk. This is supposed to be interactive. So you're saying that his point was that it was another set was a mistake. Maybe I actually prepared this slide like long time ago, so that might be something that you're right. Okay, let me go back to here. Okay, so so we have two A's here at least, and then we iterate over over A, the array, which the C++11 range for loop would give you. So the interesting part here is that we don't take it by reference. So we might make a copy here. I kind of say might because we need to think if there is also if copy actually happens here, it might happen. And then we call the function and we do it twice. So the idea is that we definitely have AA and CC, right? The question is, do we have copies? What do you think, people?
You don't want copies. It should say auto-ref X.
Yes. So Marshall, you think there are copies here? Like there are going to be two copies like this?
I do.
Okay. Okay. I also think about that the same. Its difficulty is 1, so it shouldn't be tricky. Let's try this. It's incorrect. Okay. What other can? So, but first of all, do we agree that there is a AA and CC? Is this looks reasonable? I think so. Okay. So So it's not, there is no BB here, so there is no copy. Is there any copy elision happening here by any chance? Is the compiler would, like if there is copy elision, so it's going to be AACC, which is not the case.
So would it be AA BC BC? Like would they interleave? So you have BC BC?
Oh yeah, right. That's completely my mistake. So it's AA and then BC and then another BC, and this is probably correct. Yeah, of course. So we had it correct, but not in the right order. Thank you. So this is one. Let's do another one. Okay, just make a copy of that one so we have it. Okay, so so we have class B and class A. So this basically is, this function is a friend of B. Okay, so let's start with the easy stuff. So A, and so there is a constructor, so this would be A. And then A dot create B, so A dot create B would return B, which would just return B. And I think here there's definitely going to be copy elision here, like B would be constructed, I think, and that's it, right? Is this correct? So Marshall, what do you think? There's going to be any elision here happening?
Sorry, I've been on the phone.
Oh, sorry. So A dot create B would just return B. And I think this whole thing would just have one B, because this is going to be probably elision. If this is in 17, this whole thing would be just a B. I don't know why there is this friend. This is kind of concerning. I don't see, everything here is public, and I don't see any reason, but I don't know if it's just to confuse us or not. So I would kind of guess that it's AB, but is anyone think differently? Let's give it a shot. It's incorrect. So it's definitely, we have A. This is for sure. What else do we miss here? Any ideas here? Anyone? It's actually an easy question. Any guess? Anyone want to say it again?
EAAB?
2 A's?
Yeah.
Okay, 2 A's. Why 2 A's? Like, where is the second A coming from? I would assume maybe two. It would be two, maybe two, more than one B, but which I kind of am surprised, because I thought that the whole thing would be.
Okay. I would like to change my answer. It will be ABB, because we are creating a new B as well. So
It's also incorrect. I don't know if this friend is kind of.
There's not any output on any copy assignment or copy constructing. So
yeah, it's just when creating, yeah, it's just so A would definitely be something that would happen. I don't know why we have this friend here.
So is that friend B, isn't it just creating the B again? So it would return the B? Maybe that's what's going on?
So this is the signature of this guy.
Right, so that's returning a B, isn't it?
Yeah, it just saying, okay, this, so basically this function, if we had private elements, this function could access, like in other words, if B constructor was private, this function would be able to access this private constructor because it's a friend of B. But I don't see any reasons to have it. But I might be wrong. We definitely. So we have another try until we get, and then we can take a look at. Oh, let's take a look at the hint. Okay.
So, hey, Kobi, is the friend declaration legal? It's sort of like a forward reference, isn't it?
So a friend is basically, if you look at, let's take a look at Godbolt. Okay, let's do something very, very stupid. Okay, so yes. And let's say it's just doesn't matter. It's empty. You could do default, but that doesn't matter. And I have I'm gonna do something like this. Let's do class here, but private. Say okay. So kind of making up this as we speak. Okay, and I am gonna make okay, friend void f s. Okay, let's let it compile. Let's just see it. Okay, so this is legal. So basically in this specific syntax, since create B is in A, I don't know if there is if the correct, so if can you actually have a member function? I'm not using friends like this, but can we refer to member function like this? We can do it, but when we do friends, is this something that we could do? Maybe yes. Actually, we could recreate that stuff.
Yeah, but also we're declaring the friend before the actual function has been declared, all right? The function isn't declared until below.
Yeah, that's why you have this class A. You mean well, I think this is still fine. Like the compiler would say, okay, this is class A and this is a function member inside. So for now, it's when the compiler sees that, it's okay. For now, it's fine. But let's take a quick look without.
Yeah, let's try and see if we flip class A and B, if it makes a difference too.
Okay, so let's do this. Let's take a look at this. By the way, did we try the hint? Yeah. Where's the hint? Hint. Does B have to know about A in order to declare A as a friend? Okay, which might be the issue, maybe. Okay, so if we do this, is there's going to be an error. Yes. So this is the issue. So it's actually not compiling. Okay, I learned something new today. Okay, let's continue. Book recommendation. So by Jonathan Bucera. So this is the same person that we looked at this name type. So he has a book on legacy code, and very good discussions in this book about how to approach legacy code and how to learn what is good and what is bad code and how it looks like, and how reading good code can teach you how to actually write good code, and where do you find good resources to read good code. Also talking about techniques to handle legacy code like filtering on control flow. So think about if you have if else and things like that, you can basically kind of remove some of the noise and just and he has this tool that actually does it for you, just to get the skeleton of the logic, especially when you have a very, very big function. You know, every function starts with a couple lines of code and becomes like 1,000 and 2,000 lines of code of one function. Obviously, no function started with 2,000 lines of code. It's just after a few years, it became like this. Using flame graph is another approach. And he talks about how to find source of bugs. And I would actually, and he talks about refactoring techniques. And one of the things that I would also add is that there are tools like SourceTrail that is free, that gives you a way to browse code, and it's really helping to understand not only legacy code, but code in general. So check this tool because it's really nice. Okay. Marshall, would you like to take over?
Sure, I'm going to have to figure out how to show a slide deck.
Okay, I'm going to stop sharing.
Okay.
I'm still recording.
Uh-huh.
And you can try it out. Are you using a desktop app or it's a web app?
It's in the browser. Yeah.
It's in the browser? Okay. And I know that there is Teams in browser, but I never used it. So let's see if it works.
Right. I'm just looking here. What have I got? I'm looking for a way to share my, right, share. There we go. Share. Just a second. All right, hang on. All right. That one. Let's see how this works.
Yeah, works.
Anybody see anything?
Yeah, it works.
Good. All I'm seeing is a KC, so I'm assuming that it's showing up. All right. So this is a fairly simple topic, but I keep seeing questions about it and people getting it wrong on Stack Overflow. And so I thought I'd talk about it a little bit. And it's about customizing some of the standard containers and how you can do this. I gave a talk about this a couple of years ago at CPP Con, but it was almost all about allocators. And I'm not going to talk about allocators at all today. So just so you know. Just a second. Okay. So the way the method for customizing containers is you pass them various functors. that change the way that the containers behave. And the first question, of course, is what's a functor? And the functor is really simple. It is something, some data structure that can be called with the function call syntax. So if you have a functor of whose name is f, you can write f open paren parameter list close paren, and that will invoke some code and it will do something. There are a lot of things in C++ and in the standard library that can be called like that. The obvious one from C is you have a function pointer. You can also have a struct or a class with a method named operator open paren close paren. That's the function call operator. In C++ 11 and later, we have lambdas, which are basically syntactic sugar for structs with a function call operator. Really convenient, but that's really what they are underneath. std function is a data structure that you can build up with type erasure and stuff that has a function call operator. It could be something else. You can write your own classes or your own data structures or your own objects that respond to this kind of syntax. That's all fine. Okay, so I'm going to start with the associative containers. We talked about that. So we're going to talk about the ordered associative containers. Okay, but first I'm going to digress for a second. The standard library has two kinds of containers, which I think it's kind of odd the way they break them down. There are sequence containers and associative containers. And you might think that because there are these two kinds that they are antonyms of each other, but they're not really. They're kind of, they do different things, but they're not opposites of each other, except in a very narrow sense. And the very narrow sense is that in a sequence container, you control the order of the things that go in the container. And associative containers, you don't control the order. And you can look, but the reason they're called associative is because you can look things up by value. The not controlling the order is kind of a side effect of the associativeness, as it were. But anyway, so there are 8 associative containers. They come in 4 pairs. There's 3 ways to slice them, and you could pair them up however you want. You could pair set multiset, map multi-map, unordered set unordered multiset, unordered map. You could so you could pair them up as set versus map. You can compare it versus single versus multi. You can compare it versus ordered versus unordered. But either way, there are basically 4 pairs, and how you want to look at it is kind of up to you. But I'm going to talk about, just for this talk, I'm going to talk about the single ones, not the multis, but everything I say applies to the multi ones. So we have set and map, and these are the declarations for them. Their templates. Set contains a key, a comparison functor, and an allocator. Map contains a key, a value, a comparison functor, and an allocator. Again, I'm not going to talk about allocators. Okay, what do these comparison functions look like? Imagine, for the purposes of these examples, I'm going to imagine you have a type called a person, and it has a field called a last name. Okay, and we can even say that's a string. That's fine. Here's an example. Okay, in this case, in these examples, I'm going to use this. I'm going to declare a struct. I'm not going to use a lambda. I'm just going to declare a struct. Personless has an operator, function call operator that takes 2 const references to person and returns whether or not the last name of the left-hand side is less than the last name of the right-hand side. This is very simple, but there's a few things to notice here. The first one is you take the parameters by const reference. They don't have to be const reference. You could take them by value. Don't take them by modifiable reference. You're not supposed to change them. If you take them by modifiable reference, your program will not compile, because in set and map, the key types are const. Okay, people make that mistake a lot once. Your function should be, can you people see when I highlight something here? I just highlighted the word const. Right, you can see that, great. You want to make your comparison functor, your operator bracket, your operator function call operator, overload Cots. This is not required pre C++ 17. It is required for C++ 17 and beyond. But you'll get some very weird compilers if you don't do this. Imagine you have a map that contains, product numbers and information about a product, and you have a function that calculates information about, that looks something up in the map and calculates information about it. And so, you don't like global variables, so you pass the map to this function. But you don't want to copy it, so you pass it as const reference. And then you try to look something up in the map, and you get all these compile errors, and it comes down to the fact that your comparison function isn't const. This comparison object that we're looking at here is going to be part of the set or the map. And if the set or the map is const, then all of the member variables of the set and the map are const as well. So you really want this function call member function to be const. Okay? All right. Next one. So here's an example of using set. Okay? The first one, set person1 won't compile because the default comparison operator in set is basically the less than operator. And there's no built-in less than operator for person. At least I haven't defined one. Okay, if you define a global less than operator for person, then that will work. You can define a set person less. That will work just fine because the constructor for set will default construct, the default constructor will default construct a comparison object. Now, since it knows what type to do, you can also say set person S3 and pass a person less in as a constructor argument in C++ 17, and it will in fact use template argument deduction to determine that the second parameter should be person less. Set has a nice collection of constructors. One of them takes a comparison function and an allocator, and they're both defaulted. So if you pass a comparison function, you get a default argument, and set template deduction works. If you have, using my set is you set this type, and then you can effectively default construct it because the constructor has all the default arguments. Okay. But the question is, and what people have a lot of trouble with is, what are the requirements on a comparison function? The standard uses the term strict weak ordering in various places. And this is what the comparison function has to actually impose. And people have a lot of trouble with this, okay? There are 3 requirements for strict weak ordering. The first one is identity. When you compare things, you compare something to itself, your comparison function always has to return false. Okay, your mental model should be less than, because that's the default. So comparison function of AA is always false, because A is never less than A. Okay, people like to say, oh, I want to sort things in reverse order, so my comparison function is not less than, it's greater than or equal. No, that's not. your comparison function should be greater than in that case. In any case, if you get these wrong, bad things will happen. Your program could crash. You have undefined behavior. Your program could crash. Things will not be in the right order. Something very strange will happen. The second one is for all values A and B, if comparison of A and B is true, then comparison of B and A is false. Okay, again, think less than. If A is less than B, B better not be less than A. And the third one is transitivity. Is if comp AB is true and comp BC is true, then comp AC is true. And again, you just keep going back to less than. Write it down. If A is less than B and B is less than C, then A is definitely going to be less than C. Now, there's a interesting thing here. These don't have to be true for all the possible values of your type, just for the ones you put in that container. So less than is a perfectly fine comparison function for floats and doubles, as long as you don't have any nans. But yeah, this is the thing you need to, when you're writing comparison functions for sets, well, and for sorting. Yeah, somebody commented, comparison functions are easy to get wrong with priority queue. Yeah, well, it says just crashes. Well, you have undefined behavior. If you're lucky, it will crash. That's probably the best outcome. It crashes, because then it tells you right away that it's wrong. The worst ones is when it gives you subtly missorted data, or even better, it works for a lot of things and then occasionally goes wrong. Anyway, any questions about the comparison functions for the associated containers? Okay, for the unordered associative containers, this is the declarations for them, and you notice that they have two functors. They have a cache and a predicate, and the defaults for the hash are std hash, and the default for the predicate is standard equal to. And this is basically comes out of the fact that they're implemented as hash tables. They use user-provided hash functions and comparison ops. The thing to remember is, unlike the ordered associative containers, the comparison op implements equality, or if you prefer equivalence, and not less than. And the hash functor and the comparison functor are required to play well together. They're required to be consistent. Okay? What does that mean, play well together? What does it mean to be consistent? It's easy to discover if you think about how hash table works. Like, hash table is a bunch of buckets, and in a lookup function, the hash function chooses the bucket, and the equality function finds the item in the bucket. So if two elements are equal, they have to hash to the same value. There's the relationship right there. Okay? If two things compare equal via the comparison function, their hash function, the results of the hash functions have to be equal. If you get this wrong, bad things will happen. The converse is not true. Two things that are not equal may still hash to the same value. Consider strings, okay? When you hash something, you get a uint64, okay? That's a lot of different possible values. But when you think about a string, there are way more strings than that, possible strings than that, just because, well, strings can be bigger than 64 bits, right? You can have way more than uint64 worth of strings. So it's going to happen that you have two strings that hash to the same hash value, and that's fine. That's not a problem. So what do these things look like? Well, here's some sample ones, and I'm just going to be lazy here. I'm going to say person hash takes a person, a single person by const reference, and again, it's const. And I'm going to say, I'm going to take std hash of string and his hash the last name. Now, in these examples, right, comparing by last name and comparing and hashing by last name and so on is probably not the best thing, because a person probably has more information than just this. And in the examples for say the ordered set, or these sets, if you had John Doe and Jane Doe, you couldn't put both of them in a set because they would hash to the same value and they would compare equal. Or in the ordered set, the comparison function would say these are the same, and you'd only get one of them in the set. But this is an example, so. And for EQs, do the same thing. If we just compare the last names. Now this is fine, okay? These work together since we're hashing. We know that std hash string gives you good results, and it plays well with operator double equals. Okay, so now let's look at these examples down here. Unordered set person. There will not compile. It won't compile because there's no std hash specialization and no operator double equals for person. You can define those if you want, and then you don't have to actually you don't have to define your own and pass your own hashes. Here I'm specifying them explicitly. It would be nice if you could just say person hash person EQ like we did for the ordered set, but this doesn't work. And the reason this doesn't work is because the unordered set has an amazing collection of constructors. I mean, if you look at it in C++ reference, you'll see it has an awful lot of them. It doesn't have one that just takes a hash and an EQ, because I believe it's really hard to disambiguate that between ones that take a bunch of other things. That there are so many constructors that keeping them disambiguated is hard. And that's why the unordered set don't have these constructors. Anyway, that's about it for the unordered containers. Oh yeah, one more thing. Everything I said about the unordered associative containers, ordered associative containers, the strict weak ordering setting, applies to all the sorting algorithms, sort, partial sort, nth element, etc. All of those, and to priority queue. Someone commented in the chat that, yeah, comparison functions and priority queues, if you get them wrong, they may just crash. Yes, it's true. But it's the same requirements, okay? It's not like this, they made up something different for the ordered associative containers and the sorts. They're all the same. So your takeaways are, it's easy to define your own things here. You just have to get a few simple things right. For the for the unordered ones, you have to get your hash and your equality playing nicely together. And for the ordered ones, you need to make sure that you fulfill the strict sorting requirements. And that's about it. Questions? I hear none, so I will stop sharing. Thanks.
Thank you. Perfect. Looks good. Thanks, Marshall. So we have another, say 15-20 minutes. So let me show you some stuff about variant. Give me a second. I'm going to share it.
There was a question on Stack Overflow yesterday that just made me roll my eyes, because somebody had a question about variant, and he had two different variant kites and he put them in a union. And I was like, what are you trying to do here?
Yeah, there's other stuff that I'm seeing with variant, but anyway. Okay, 1 second. I'm gonna share it. Okay, let's talk about variant. So I'm going to talk about motivation and how variant. Okay, there's a lot of things to say about variant, so I'm going to talk about just a few aspects. Let me just increase the font here. And I'm using the Compiler Explorer. It's going to be some interactive session, and I'm going to show at least one motivation. There's a lot of them, and let's start. Okay, so I'm going to just create some simple includes. Okay, so let's say you have a class or a struct, doesn't really matter, of a car. Let's say this is a, I know we don't need anything, and this class car has a function named drive. Another type, pedestrian. I'm gonna make it short, pedestrian ped. And also final, nothing special here. And pedestrian can walk. Okay. And we have main. I'm gonna make some interesting main. I showed it in Qualcomm just for fun. This is a valid main. Just for fun. Don't do that. Just not. It's not their ordinary ways to do that, to define main. So let's say we have a vector. So let's do this. And I want to put all the cars, and I have all kinds of cars and pedestrians. I want to put them in this vector. So I want to have a vector of let's say objects, and I want to put here. Let's say I want to put a car, and I want to put a pedestrian, and so on and so forth. But obviously, that's an issue because what would be the type of the vector? So in a lot of cases, give me a second. I need to turn on the light here. 1 second. Okay, I'm back. It's become very dark. Okay, so in many cases, what I usually see is I just curious to hear if anyone else has the same experience. So people would do an object and in the good case, people have like an object virtual destructor, and now what I can do is basically I can inherit and that makes my life pretty easy because I can actually go and do something like this. Object pointer, and by the way, before I continue, so what another option that people would do if they agree not to have a heterogeneous container, they would go and do something like different containers for cars. So they would have car here and then multiple cars, and they would go and do something similar here. for pedestrians. So that would be one of the solutions that, okay, I'm unable to put it in the same container, but so I'm going to create a different container. So this is another option. But most of the time I see this system where people would create a fake base class. There is no relationship between car and pedestrian, two different things. They create this fake hierarchy. And so I have this object, and now I can do something like this. So I can do new car and new pedestrian and another car and all good, right? So, and let's call it objects 3. That's fine, but few things you need to understand. So first of all, you need to remember to delete. And sometimes the heap is not the best solution that you wanna use. You pay for virtual table, you pay for virtual pointer. So virtual pointer would be in every instance. Virtual table would be increase the size of your executable and so on and so forth. So you basically pay for increased size. There's another thing that that usually comes with inheritance is that there is a technical depth on the design, on the reader, on maintenance. And obviously for the first thing that I mentioned, you need to remember to delete. So there is a way to do something like so I can do something like this. And I can in place or push back or all that stuff. So I can take objects 4 and in place back. Car, and I can do the same thing.
Are we going to talk about exception safety in those 2 lines?
No, I'm not talking about exception safety. Thank you for bringing it up. I don't have time to talk about it. Do you want to mention something if it's quick, because otherwise we're gonna spill to after 8.
Sure.
But
if the in place back fails for any reason, you've leaked a car.
Yes.
Or a PED in the second line.
Yes.
That's
True.
all I wanted to say. Yes.
Thank you. Yeah, I'm not talking about about exception safety here. So this is one approach that I'm seeing a lot during code reviews and all. But if you're using either Boost, if you're allowed to use Boost, or you're using C++17, so Boost has Boost variant and C++17 has Std variant. The same concept apply. So let's see how Std variant can help us. So I'm gonna include variant here. And just a quick like 30 seconds on variant. So variant basically, just like Marshall mentioned before, kind of hinted, it's basically a glorified union type, more type safe, and we don't need to we don't get into undefined. So in C, you get an undefined behavior if you assign to one of the union members, but read, for example, from a different union. Sorry, in C++, it's an undefined behavior. In C is fine. In C++, it's undefined behavior to have an active member and then refer to a different one, which is not the active member of the union. In C, it's fine. This is how people use all kinds of tricks for like punning and like reinterpret cast and things like that in C. But in C++, there is an issue with that. So so it's glorified union. It's just more type safe and all. And I show how it can make your code better in with respect to the other approach that I showed above. Okay, so let me create a type def here. With object variant, the type, and just to help me type less. So I have a variant of car and pedestrian. Now I'm able to create a heterogeneous, kind of a heterogeneous container, in this case vector, of obj var vector of objects. And again, I can do car, I can do pedestrian, and digest the whole thing. Yeah, I have a typo here. Okay, so here we have heterogeneous vector of two different, and if you don't really believe me, because we still have that, so let me do this. And obviously this would so you see no magic here. Let it compile. It's completely heterogeneous. They are not inheriting from any object and all good. Now there's a lot of all kinds of functionality that comes with variant that I'm going to show just really few of them. But feel free to go and start looking at what kind of things variant gives you. So what we could do is, for example, I can something like that. I can get the index of the index. So variant has types, right? I can take a look at when I look at the specific instance, I can extract the index of this instance. So I can do something like vector of object dot, let's say, font. So I know in this case, in this example, it's going to be car, and then index. So if I just return car index, by the way, you can see that the return value would be 0. Yeah, program returns 0. And if I do the same for the other one, it's going to be, let's say, back. I have only 2, and the back is the pedestrian, and let's do ped. And it's the second element of the type in the variant, so the index would be 1. And this is what we see here. And again, there's so many of them that I encourage you to take a look. Now, what else I can do here is I have, let's say, auto, in this case, and I can do stud get of car of the font. Now, if I'm screwing up on that, if I'm not mistaken, I'll get an exception here. In this case, I know that it's fine because I get that. I know that the first one is car, but I think that it's. Let's take a look. I think the back would give me an exception if I'm not mistaken. Yes. Okay. So so this is another way kind of to extract the information. You can also do something like give me car index. So remember the car is index 0 because it's the first one in the variant. So that also would work for me. So that's another thing. Now, definitely can say, hey, Kobi, you actually know the layout of the vector because you're pushing car and then pedestrian. So you actually, when you do get, you have this this knowledge that you know what to get, and obviously you get exceptions if you try to extract the wrong type. Variant gives you all this type safety, but is there anything else we can do in order to get things extract in a more generic fashion? So there are a couple of approaches here that I'm gonna show. One is kind of more straightforward, and one is kind of more advanced, and you'll need to kind of hopefully, if you have questions, I can answer. So visitor. So if you take a look at examples of variant and visitor, so what I'm going to do, I'm going to use studVisit. So I'm going to create a visitor which is a callable object, just like actually very close to what Marshall mentioned, a functor. And I'm going to use studVisit here. StudVisit of the functor, which is a simple visitor, and a callable object. So let's take, for example, okay, let's do this. Something I don't know what it is. Equal vec of objects. Let's say I don't know what it is. So I'm going to take this variant and invoke it on the callable object, and let's see what happened. So let's go to this visitor, which is a call, and start populating it. So I'm gonna have two call operators, like parenthesis operators, like. So if you remember, this is the syntax, and these are the arguments. So one of them would take car, and then I can do c dot drive. One of them would take pedestrian, and pedestrian would work. And so here's a very cool way when you're holding a variant and you want to do something with it. studVisit allows you to take this visitor that I created and basically the right function according to the actual instance that this variant holds. If it holds a car, this function would be invoked. If it holds a pedestrian, this function would be. So in this case, it's going to be a car. So I'm going to show you how this one is being invoked. I'm going to just do assert here, just to show you that it's going to trigger. And it's triggered. So basically we are something is basically a car because this is the function that was invoked. And you can do a lot of things. Like if I wanna do something, like I can have a template that would catch everything else. If tomorrow there are more types that some people add to. I'm not right now. I'm passing everything by value just for convenient, but you need to either pass by reference and things like that if needed. And I can do something like like printf or assert, not impl yet. So if someone add another element to the variant, so this would be a catch-all of everything that is not a car and not a pedestrian. So there's a lot of things that we could do here in order to extract. So it's a very cool framework that is type safe and allows to relate to the right type in a more safe, or say safer way than, let's say, union. And I sometimes I see people holding an enum with the variant. You don't need to do that because the variant itself keeps it has the bookkeeping done for you about what kind of object. So you don't need to have an enum of a car and pedestrian and keep track of what you're doing and all of that. You don't need to. This whole thing is kept by the variant. If you have a bit more energy to see an improved way to work with variant and this visitor, I can give you another 10 minutes. This is something that long time ago I looked at, and I think, I don't know, Marshall, if you remember, but I asked you about that, and it was puzzling initially. So there is this, if you look at stud visit on CPP reference, they are referring to this overloaded pattern, which I thought there is a paper that kind of make it part of the standard library, but I'm not sure where the paper is, if it's going to direction of, yeah, it's going to be something in 23 or beyond that. So I'm not sure. But, so here's the thing. So the trick is the following. So you have you create this visitor by doing the following. So using a variadic template. So just like I had this visitor, I'm going to create the same thing, but it's kind of going to be a generic one, and they call it overloaded. I'm going to public, since it's Struct, is going to be public inheriting from all the objects that are being passed as a parameter, template parameter. Okay. And the last thing, I want to bring all the functions, and I'll explain what does it mean, into the scope of overloaded. So I'm going to do this. This is, the syntax might look a bit scary, and that's fine because it is scary, but basically things would get clear soon. It's basically a class that has a template parameters, and it inherits from all the template parameter, assuming that all of them has operator parentheses defined, and we bring all these functions into the scope of overloaded. We need that in order to use it. Okay. And the last thing that we have here, which also mentioned in Marshall's presentation, is the constructor template argument deduction, CTAD. So it's kind of another. So we're going to do this. So this template class S would be of overloaded. So this, that gets all this as if I did this. Okay. So let it compile just to see that everything is, I didn't do any time. Okay, so now, so same deal. I'm going to do stud visit. So as you probably remember, stud visit has two things. One has the variant that I'm going to use and some label object, right? So I can have callable objects that are lambdas. That's one thing. But I can, since I have this overloaded struct, I can actually instantiate this struct with a bunch of lambdas. Each of them would be this TS here. So I'm going to show. So each of them would be a TS. And lambdas, internally, they have operator, when the compiler actually create the struct for the class for us, they have operator parentheses. So what I'm going to do is the following. So I'm going to create an instance overloaded. So it's a struct, right? And I'm going to start fill all kinds of callable objects here. So my first callable object would be a lambda that has an argument of car, and it's going to do c.drive. And the second one is another lambda. And this one would be I'm a pedestrian who is walking. And of course, I can do another lambda that has catch all, but let's keep it simple for now. And I need to close this guy. And that's it. So I'm actually created the same idea as this guy, but instead of having this sample visitor outside, I'm actually creating this this callable object that has multiple parentheses operators. I'm creating it in place as the first parameter to the stud visit. So each of these lambdas, each of them would be this TS. And lambdas are basically, if you look at CPP Insight, if I click on this CPP Insight, basically you can see that lambdas are just classes. Here. Lambdas are just classes. Here's another one. And the nice part of them, they have this parenthesis operator. So going back here, I'm just inheriting from classes. Lambda is just a class. I'm inheriting from all of them. And I'm bringing the operator or parenthesis into the namespace here. When I'm done with all of that, I basically have a callable object with all these parentheses, just like I have this sample visitor. I'm going to end up with a very similar structure. And then stud visit can take something and match it to whatever it is. If it's a car, it's going to dispatch it here. If it's a pedestrian, it's going to dispatch it here. And this is basically how you can use variant in your C++ applications, and basically treat it. You can put it in a heterogeneous container and treat these variants in a very seamless way. Okay, let me see if there are any questions, because I kind of didn't see. Okay, so Marsha says pointer vector would help with the deletion. Okay, I didn't know about there's so many things in Boost. Are we abusing inheritance? Oh yeah, for the first one, Chetan, is that if you're asking about the first the example above that I started off, this one? Yeah, we're definitely abusing inheritance. That's really the whole point. Using twice the memory, or is it new? So it's using placement new. Yes, again, okay. I forgot to mention that just like union, it needs as much memory as the largest alternative. So this is basically a trade-off. If you have pointers, it's just in the container, just pointers. But if you're using variant, each of them would be the largest one. It's a union inside, but not using a C union. So basically, Marshall, if it's not using C union inside, what other? I'm just curious, what other approaches they use
It's just a block. Just a block of storage.
Just a block of storage. I see. Okay.
And then you can do placement new into it. And,
yes.
And you can call the destructor on it, and then you can placement new a different type into it.
I see. So optional, for example, also has just a storage and you do placement new on it.
Yes.
Okay. Awesome. Perfect. Hopefully you learn new things. I do see that this makes the code so much more readable and so much shorter than lots of ifs and things like that. Think about it. There is no if here. I'm dispatching the right instance according to the type to the right location of the code. There is no if here. It's a very clean approach. If I would, I can definitely see it in my day-to-day application when I working with people and introducing stud variant. I'm using C++ 17, so I'm kind of being fortunate to be able to use this this new elements of the language. Any other questions related to this? Okay. I think that's it for today. It's 8 p.m. Hopefully you enjoyed, and hopefully I'm going to see you again next time. Thank you all. Thank you, Marshall, for your presentation.
You're welcome. Thank you, everybody.
Thank you, everybody. Bye-bye. And
Bye.
yeah, I'm going to try to approach people to get this 20 minutes just to share stuff would help me. Thank you.